Welcome to Brain Vision.
We have two different bodies here, so we will study them separately. First, we draw the FBD for the cylinder along. The cylinder will be called A, like in the book, and the carriage B. As you can see from the FBD, taking the sum of moments around the center of mass that yields mass moment of inertia, so it can be written as sigma mg is equal to I alpha, but sigma mg is equal to f r is equal to 1 half ma r square alpha. So we can write alpha is equal to 2 mu g upon r. Also taking Newton's second law around the x-axis, we can write sigma fx is equal to ma AAX. Therefore, AA is equal to mu g. I changed the name of acceleration from AX to A since there only is acceleration in the x direction for the center of mass. So it doesn't need to be denoted and it's easier to understand. Now, if you have solved enough of these problems, you should feel that we need a relationship to relate the angular acceleration of the cylinder with the acceleration of its center of mass. Now, if instead of the carriage, we would have solid heavy ground that isn't affected by the force of friction the cylinder applies, we could write that for the no sliding. So accordingly, and accordingly, I can write the equation as AA is equal to alpha r. However, that is not the case here. So let's think of how we can make that the case. If we can make the carriage not move with respect to the cylinder, then we can use the above equation. It turns out this is pretty easy to do, since for the relative acceleration, if we subtract the acceleration of the carriage from the acceleration of the cylinder, then to the cylinder the carriage appears to not be accelerating at all. In math term, this is translated to alpha r is equal to alpha b minus alpha a. Sorry, alpha r is equal to ab minus aa. Now let's draw the FBD and then study the carriage we named B. You can see it in the diagram. Taking Newton's second law in the horizontal direction, we can write sigma fx is equal to mb abx. Therefore, AB is equal to P minus mu mag upon MB. Note here, if you are wondering why I have only added the mass of the carriage in the above system, not that of cylinder 2, it is because they are different systems and they only interact by the force of friction and reaction force between them. We have four equations and four unknowns. All we have to do now is solve the system. So I can write alpha r is equal to AB minus AA. But alpha r is equal to 2 mu g upon r into r is equal to AB minus AA. And by putting this A equation here, that means which we are having mu g minus p minus mu mag upon mb is equal to 2 mu g. Here r will be cancelled out. And solving this in the form of mu, I can write mu is equal to, simultaneously we are putting the values here. So mu is equal to p, that means 4, upon g, that is 32.2, into 3 times mb, that is 6.32.2, plus ma, that is 16 upon 32.2. And solution of this will give the answer 0.1176. Now using this we can find the values of the acceleration of the carriage. So that is nothing but AB is equal to mu g, but mu is 0.1176 into g is 32.2, which gives the answer 3.79 feet per second square. And the acceleration of the cylinder A is can be calculated as AA is equal to P, that is 4, minus mu, that is 0.1176 into M, that is 16 upon 32.2, into G, that is 32.2, upon MA, that is 16 upon 32.2, which gives the answer 11.4 feet per second square. Next, to find the distance the cylinder has rolled with respect to carriage, we need to find the acceleration of the cylinder with respect to the carriage, which we before found out. That was alpha BA is equal to alpha R is equal to alpha B minus alpha E, or AB minus AA. That means AB is 11.4 minus AA is 3.79, which is equivalent to 7.61 feet per second square. The translation motion in the straight line, which constant acceleration is given by x is equal to x0 plus v0t plus alpha BA times t square upon 2. Since the system starts from rest, then x0 will be 0, v0 is also 0, and t is equal to zero point 0.5. So let's put the value here. So we will get x is equal to 0.951 feet because we have x 00, v 00, and t is equal to zero point 0.5. Okay, so finally we have this x.